In this example, xt is a periodic signal and its Fourier series coefficients are given. We are asked to determine whether xt is real or not, whether it is even or odd, and whether its derivative is even or odd. First part is the signal real. To solve this, we start with an important property. If a signal is real, then xt must be equal to its complex conjugate. That's the first key point. Now, the second point, if xt has Fourier coefficients ak, then the complex conjugate of xt has coefficients a minus k conjugate. So, using these two facts, for xt to be real, we must have ak equals a minus k conjugate. Now we check this condition. We already have ak. Next we form a minus k. Then we take its conjugate, a minus k conjugate. After comparing a k and a minus k conjugate, we see that they are not equal, so we conclude this signal is not real. Second part is the signal even or odd. A signal is even if xt equals x minus t. Now again, using Fourier series properties, if xt has coefficient ak, then x minus t has coefficient a minus k. So, for the signal to be even, we must have ak equals a minus k. Now we compare these two. We see that they are equal, so the signal is even. Third part is the derivative even or odd. Now we need to check the derivative of the signal. First, we use another important property. If xt has Fourier coefficient ak, then the derivative of xt has coefficient jk omega 0 ak. So we define new coefficients. bk equals jk omega 0 ak. Now we analyze symmetry. For the derivative to be even, we must have b k equals b minus k. So we compute b minus k and compare it with bk. Because of the sign difference, these two are not equal. So we conclude the derivative is not an even signal. Final summary: the signal is not real, the signal is even, and the derivative is not even. Problems like this are very important in Fourier series analysis, and we have many similar examples on this channel. If you find them helpful, feel free to follow the channel.